about why are we doing this video or what is this video talking about. We will show you something incredible.
So keep watching and
check it out!
Yeah.
The first thing that we do is thinking about what kind of problem that gonna be our team's topic. After we discuss together with our team, we find nothing. We are stuck. We're starting to go out for looking for some idea for our team's topic. We face several everyday issues.
Firstly, we often find skater hair around the room, especially women's hair. Additionally, we sometimes encounter problems like skater paper scrap. Another example case is when working on a project and using styrofoam material. These styrofoam pieces are difficult to clean up.
Having a vacuum cleaner can make it easier for us to clean the dust and dirt.
However, buying a vacuum cleaner from the market or marketplace can be expensive. Therefore, we realized that there are still many items like electronic waste that we can reuse.
The research phase of the EDP is vital for developing an affordable and environmentally friendly vacuum cleaner. It involves thorough investigation through literature reviews, expert consultation, and online research to gather relevant information and explore options.
The research focused on advancements in design, materials, and technology to minimize environmental impact and promote sustainability.
In the solution phase, we focus on developing innovative solutions for creating a vacuum cleaner from inorganic materials.
Based on the research and analysis conducted, we have designed several effective solutions.
One of the solutions we discovered is to use larger and more efficient dynamos, such as those found in used fans. We adjust the design and size of the blades to ensure optimal airflow and strong suction power. Furthermore, we see potential in using recyclable inorganic materials to build an environmentally friendly vacuum cleaner.
so these are the tools and materials that we use in making a vacuum cleaner.
So how to make this vacuum cleaner? Check this out.
The first step, we have to cut a used laminar bottle in half according to the agreed size. The second step, we have to make a hole in the bottom part of the bottle. The third step, we have to make a propellers or the blades from the used bucket lids that are formed into circles smaller than the diameter of the used laminar bottle. The fourth step, we have to determine the number of wings of the blades according to the number pattern that has been discussed. The fifth step, we have to make a filter from mesh fabric, which is formed into a circle with the same diameter as the used laminar bottle. The sixth step, we have to connect the dynamo with used fan wires. We attach the blades to the dynamo for testing. We conducted the testing by connecting the dynamo to a power source. The seventh step, we have to attach a short hose to the top of the bottle. And the last step, we make a handle as simple legs from the vacuum cleaner from carton.
The first phase of the prototype for the vacuum cleaner production.
We begin by sketching and construction in framework.
We create initial sketch to plan the appearance of the vacuum cleaner.
In the evaluation phase of the EDP for vacuum cleaner production, tests were conducted to assess the product's performance. Initial prototypes revealed shortcomings, such as blade size and distance from the nozzle affecting suction power.
Further research and testing were conducted to address these issues and improving the design.
This evaluation phase highlights the importance of testing, research, and iterative improvements to ensure the vacuum cleaner functions well.
In the refine phase, alternative solutions explored and models and prototypes developed and tested. Comprehensive analysis of materials, budget, reliability, and performance was performed
vacuum cleaner production. We used the result from the first design testing to improve and optimize the subsequent designs. We engaged the communication and discussion regarding the analysis of the testing outcomes to guide the decision-making process for the next design iterations.
This discussion allows us to gain input, suggestion, and diverse perspective from team members with diverse knowledge and experience.
After the communicating stage in the EDP for vacuum cleaner production, we return to the prototype stage to develop the second design. Based on the communication and understanding we have gained, we create the second sketch to replace the appearance of the vacuum cleaner we will make. The second sketch takes into account the input and suggestion we receive from the team and stakeholders regarding our first design.
Once we have completed the second sketch, we use it as a guide in creating the second prototype of the vacuum cleaner.
And then, the second prototype allows use to test and evaluate the design in greater detail, identify weakness or deficiencies, and make necessary improvements.
During the evaluation stage, these shortcomings were discovered in the second sketch of the vacuum cleaner. We found that the vacuum cleaner cannot suck it up. So, we found two problems. The first, we have to change the direction of the blades. And the second, we have to unmodify the body of the vacuum cleaner.
This evaluation process involves identifying shortcomings, speculating on solutions, and iteratively refining the design to overcome challenges, ultimately achieving improving the performance and the functionality. By conducting a comprehensive event stage, we were able to address the previously identified issues and achieve more innovative and effective design solutions.
This collaborative communication allows us to gather valuable insight and perspective, facilitating a comprehensive evaluation of the design change.
In this stage, we create the final sketch based on the improved design to plan the vacuum cleaner's appearance and components. Afterward, we build the last prototype ensuring compliance with the specifications.
We test the suction, capability, noise level, durability, and overall performance of the vacuum cleaner.
The learning derived from project-based learning with a STEAM approach will enable students to develop knowledge and skills in the field of science, technology, engineering, arts, and mathematics. Here are the components of STEAM. First, there is science. Science components of a vacuum cleaner are located within. The production of vacuum cleaner greatly aids in recycling and repurposing inorganic waste into organic materials and electronic waste into useful everyday items. The presence of a simple vacuum cleaner will adeptly help us in maintaining clean lines and is an example of a vacuum cleaner made from used bottles that are effectively designed with various attractive designs. For the second, there is technology. By utilizing online reference, we are actively researching and exploring a wide range of intriguing designs for the blades of a simple vacuum cleaner. Additionally, we are studying the effective use of tools during the manufacturing process to ensure the creation of a functional and efficient vacuum cleaner.
Okay, next, the engineering components found in a vacuum cleaner are design and development. This includes selecting suitable components, designing the layout of the vacuum cleaner, connecting cables and dynamo, and planning the overall design of an efficient and functional vacuum cleaner. The art components of a vacuum cleaner are located within. In this process, design has the freedom to integrate visually appealing elements such as shape, color, texture, and patterns that's creating of a vacuum cleaner. Next, the mathematical components found in a vacuum cleaner are the concept of number patterns and the area of a circle. So, this is the component of vacuum cleaners.
This innovative vacuum cleaner offers interchangeable cleaning heads for different surfaces. The heads are easily detached and replaced with a clip or latch system.
The main advantage of this vacuum cleaner different lights, enabling efficient cleaning across various floors, surfaces, and homes. In the development of fun blades for vacuum cleaner machine, students may encounter challenges related to the suction efficiency, noise, and energy efficiency. Students face obstacles in making fan blades for a vacuum cleaner, namely the lack of tools
like nails to create a hole in the center of the fan blade and for attachment to a vacuum cleaner body.
We were doing the project basically using STEM approach for students, and then we distribute worksheets for 5 days.
Based on the analysis of the worksheet and interview from all groups, we can conclude that there is still a significant lack of understanding of STEM concept in the context of vacuum cleaners.
So, with exploring renewable energy, designing and building a sustainable vacuum cleaner with cylinder, it's really effective from student learning activities,
Because students can know about the component of STEM.
such as science, technology, engineering, art, and mathematics, and can solve the daily problems.
Thank you for watching and see you in the next project.